Doing these 3 whitebook problems that have been asked for this week, and I'm going to start on page 53, number 21. So on page 53, problem number 21, we're given a function, we're not allowed to use our calculator, and we are asked to figure out where this function is increasing. Well, to figure out where something is increasing, I need to go to the first derivative. Something I know about increasing functions is that the first derivative is positive. So if I take my function, I'm just going to rewrite it first. F of x equals x to the 2/3 times 5 minus 2x. And I know if I need to take the derivative of that, I think it's going to be easiest to distribute first. So I'm actually going to distribute this through my parentheses. And when I do that, I have 5x to the 2/3 minus 2x, add up these exponents, 2/3 plus 3/3 is 5/3. So that's my original. Now I need my first derivative. Now I can just do a power rule. So if I multiply here, I'm doing the power rule, I get 10/3 x to the negative 1/3 minus 10/3 x to the 2/3. To figure out where the function is increasing or decreasing, I'm always going to set this equal to 0, and then eventually I'll set up my number line. I can factor out from both of these a 10/3, and there's actually more I can factor out. They both have an x in them. I'm going to take out the smaller x, which is the x to the negative 1/3. If I factor that out here, I factored it all out, I'm just left with 1, minus, here the 10/3 is factored out. I had x to the 2/3, and I factored out x to the negative 1/3. So my rule is I keep the base and I subtract the exponents. Well, 2/3 minus negative 1/3 is just 3/3 or 1. Set that equal to 0, and then I'm supposed to solve this for x. Those are going to be my critical numbers. Well, here if I solve for x, I get x equals 0. And here I get x equals 1. So those are going to be my 2 critical numbers. I'm going to set up my number line. I'm going to put 0 and 1 on there. And then I'm going to pick some test numbers. Maybe negative 1/2, 1/2, and 2. I'm plugging these back into my first derivative because I want to see where the first derivative is positive, it would be increasing. So I'm imagining plugging negative 1/2 in. Now this right here just means that the x would be on the bottom and it would be the cube root. So if I put negative 1/2 in, the cube root of negative 1/2 is negative. And then if I said 1 minus negative 1/2, that would be positive, and a negative times a positive is negative. It's going to decrease there. If I put 1/2 in, the cube root of positive 1/2 is positive, and 1 minus 1/2 is positive, so positive times positive is positive, it's increasing. And then lastly, if I put 2 in, the cube root of 2 is positive, but 1 minus 2 is negative, and a positive times a negative is negative. Question was asking where is it increasing, and so where is that derivative positive, and it's going to happen between 0 and 1. So D is going to be my correct answer here. Okay, now I'm looking at page 78, number 27, and there's actually a mistake in the back of the book for this one. The correct answer for this one is A. Back of the book says C, so if that was the part that was confusing to you, know that it is correct if you chose A. Here's how we do it. It looks like a difficult integration problem, and so to solve a difficult integration problem, we're going to use u sub. So I'm going to pick what I think I should make u. I'm going to choose sine of x. It also might help if you rewrite your problem as 6, the sine of x squared, cosine x dx. That might be easier to look at when you're determining what you should pick for u. I'm going to pick sine x, and then I'm going to say du, the derivative of sine x is cosine x, and I'll throw my dx on the end. Remember, the purpose of u sub is to rewrite and to only use the letter u. So here's my 6. In place of sine x, I'm going to put u squared, And I have a cosine x dx left over. Well, that's the same thing as du. Now I'm going to integrate this. So this becomes 6u cubed over 3 plus c. Final answer, well, I'll divide that. 6 divided by 3 is 2. Back in for u, I'm going to put sine of x cubed plus c. And that is the same thing as answer choice A. Okay, the last one I'm going to look at is page 83, number 11. And it tells me that a left-hand Riemann sum over approximates the definite integral. And then it gives me information about a trapezoid sum underestimating. And it says, which of the following could be my graph of f of x? So the first thing I'm going to do is figure out what my left-hand Riemann sum looks like. That means I would start on the left to draw my rectangles. Well, if I start on the left, my first rectangle would be flat. Go on the left, go up, and come over. My left-hand rectangles are underestimates. So answer choice A is out of there. Let's move to this one. My left hand is over, so this one's still good. Let's try this one. My left-hand Riemann sum is over, that's good. Over here in part D, my left-hand Riemann sum is going to be under. One thing you might notice is that if the function was increasing, the left-hand Riemann sum was under. And if the function was decreasing, the left-hand Riemann sum was over. So I've done my left-hand Riemann sum, and now I need to think about trapezoids. My trapezoid is supposed to be an underestimate. Well, a trapezoid, I always like to draw just a large trapezoid, not a bunch of little ones, to see if it's going to be an over or an under. I'll go from 1 to 4. Well, a trapezoid, you go up till you hit your graph. I'll go 1 to 3. And then you're supposed to connect to this with a straight line. Well, if I connect that with a straight line, because my graph is concave up, my trapezoid, or my straight line there, is over the graph. So the trapezoid did not work there. Let's make sure it works over here. I'm going to go from 1 to 3. Go up till I hit my graph. I'm just trying to draw a trapezoid here. And I'm going to connect these two with a straight line. Well, it's kind of hard to tell, but if I draw my straight line, it is going to be under the curve. The curve was concave down, and so that straight line is under it. So for a trapezoid rule being an underestimate, it's going to be the answer C.